Hello everyone, this is Jim. And okay, let's start. Today our content is about parameter adjustment, part 1. For this parameter adjustment function, we have two parts. And for another part, I will introduce it in another class. This is our today's content. Part 1 is load initial ratio identification. And part 2 is rigidity level set adjusting. Okay, first part. First of all, we need to know why we need to set the load initial ratio. Because we need make our servo to have a good control effect on our motor. What's the good control effect? For example, this is our speed instruction sent by our driver, but in fact our motor speed may be like this one. We can see there will be a delay and also some offshot of our actual speed. So what our target is to make sure to make these delays and make these overshoots as small as possible. This is our target. So we need to set the control parameter of our driver. And before setting the control parameter, we need to set a suitable load initial of our driver. On the left part, we can see the steps to set the control parameter. First, we need to set the initial ratio. And second, we can use our software to use this automatic gain adjustment function to get a recommend rigidity level of our driver. And usually, for most applications, after these two steps, we can get a good control parameter for our system, so we can use it directly. But sometimes the control effect may be not good enough, so we can continue go down to use this manual gain adjustment to set the control parameter manually. And if the control effect is also still not good, then we need to adjust the division suppression. Yes, this is the steps. And today our training will introduce this part first. And here, what's the load initial ratio? This is the value. That's the total movement of the initial of our machinery load divided by the motor's movement of the initial. And for this value, we have two ways to get it. First way is use SC tool. SC tool use this debug function to get the load initial. And second way is use the monitoring value. This one U0 and 20. We can start the machine, run the machine, and read this U0 and 20. Read this value. After we get the initial ratio, we need to set it in this parameter, P3 and 1. Need to set the parameter here. Okay. So first, next, before we use load initial ratio identification function, we need to notice these 4 points. First one is we need to ensure our motor can be jogged normally. And here I have a link about how to jog. You can check it later when you have time. And the second part is to set the max speed of our motor during the initial identification. This parameter, we can see it is in P3 and 6, this parameter. default value is 1000 RPM, and this value should be bigger than 300 RPM. And step 3 is the movable distance of our motor. We need to ensure in both forward and reverse direction, our motor can move more than 1 turns. So it means there should be enough distance for our motor to rotate to get the load initial ratio. And at last, if there are something wrong, for example, motor begin to shock, then we need to stop the servo immediately to ensure the machine code is safe. Okay, this is the steps about how to operate. We can check it in software SC2 later directly. And here I have 2 pictures. You can see with different initial setting, the control effect is very different. Right side, the setting initial value is close to actual initial, so the control effect is good. But on right side, we can see because the setting initial is too small, so the motor will begin to shock when it achieves the happy speed, and also when it's slow down to 0. Yeah, these 2 parts, the motor will shock. Okay, so now let's connect our Servo. Connect our driver first, and in debugging page, this is the speed, jog speed, and this is the running speed. We can set a small one to make it clearly, and click on. Now we can see we can click forward and reverse to make our motor rotate. And now we can click this identify button to run the motor. Okay. Finish it. And here on this table shows the recommend initial ratio. Software give it's 93. It's about 1.1. And here we can change the rotate direction. For example, change to forward and forward. Identify again. Okay. This is 96. It's similar to 1. Also reverse and reverse. The only difference is the motor rotate direction. Okay. So it's also about around 1, the initial ratio, because in fact there are no rods connect to our motor, so this value should be around 1. So this is the first part about how to use SC tool to get the load initial ratio automatic. And the second part is electricity level self-adjusting. For this parameter, P3 and 3. Here we have 2 settings. 0 means the control parameter will according to the electricity level we set. Where is the control parameter? It is in group 2. You can see here we have first group loop gain and the first speed loop gain, and some other control parameters. So here, if we set P3 and 3 setting as 0, it means there will be a table, and in the table, for different registry level, we have different control parameter. And all the control parameter will depend on the level we set. And second, for this, if we set P3 and 3 as 1, it means the control parameter will not depend on the registry level of our motor. It will depend on what we set here. Okay, that's the difference. And usually if we use manually setting, if we use manually setting, we need to set this parameter as 1. And now here is the steps about how to get the registry level by our SC tool, and also we can use SC tool to show it. Here, after we finish with the node initial identification, we click next step, and here we click this button. Then you can see the motor will begin to rotate again. And in this table, we can see the control effects under the different level. Finally, the SC tool recommends we use 18 this level, because we can see in this table 18 or 19, these two have good, have a better control effect. So system recommend this recommend this registry level. And this table, we can see here are some recommend control parameter given by the SC tool. And then we can see here in group 2, this parameter 406, 350, 120, 35 is the value we get from here. Okay, let's the steps about how to get the registry level of our motor. And in another class, I will introduce how to set this control parameter manually. For example, if we increase this parameter, what the control effect will change. And also, for example, if we reduce this parameter, what the control curve will change. I will introduce this part content in another class in the future. Okay. Okay, that's all. Thanks for your attending.